Hello and welcome to this session. This is quite a different session where we don't have to connect any wires or terminals to Arduino. So we can simply turn off the live feed any moment. Okay, so what we are going to do is we will make a simple calculator using this 8-bit processor, which is our Atmega 328 microcontroller located in Arduino. So we won't be covering all the functions of a regular calculator. We will be simply looking into a square root and power of integer, so both in the floating point domain. So instead, as you know, there is no display connected to Arduino. We will simply using the serial monitor to view the data, and also serial monitor to send the request. So it will be like an interactive session where user will input the choice which operation they want to select, like square root or power of integer. It will be a menu driven application, and the processing will be done on Arduino, and the result will again send back to the serial monitor. So let's get started, and we won't be covering all the functions, as you know, because we have limited time, but it can be extended to any such operations. So let's get started. You know, we have to include two functions, void setup and void loop. Void main is from C. I am from C background, and that's okay. Fine. So these two functions, as you know, are mandatory. And here we have to include one function, one library, math.h, that we will see whenever it's required. So let's first build the interactive screen. So simply you have to start the serial library, serial.begin. The speed will be unchanged, 9600 baud rate. Now Okay, what I will do is, we don't need this live feed. Let me minimize this live feed. In fact, let me maximize this Arduino IDE. Although it's not required, we are just wasting our white space, but it's fine. We can concentrate on one thing at a time. So serial.println, this we can say, so as I told you, we will have a menu type entry. So let us say select operation by typing 1 or 2. Okay, so 1 for maybe a square root operation and 2 for power of integer. Serial.println, print in a new line. Here we can say 1, you can say square root. Let me copy this line, and 2 will be, let's say, power of integer. And just for a decoration, I will add a separator. So that's it. This function will run at once, and this will print a menu. So let's see how it looks. Control U to upload. Upload is done. Our serial monitor. Here we go. So it was actually shown in my other desktop, so I have to move it here. So that's all. It stays here, and now we can proceed further. Let's come to our void loop, and here, okay, so let's start with serial dot. So here we will actually read from read from PC that user has selected which option. So we know we have two options. select 1 or 2. So if user enters 1, suppose I enter 1 and hit enter, I should be moved into a new page or a new menu where I will be asked to enter the number which I want to make a square root. Okay, find the square root. So let's let me show this window continuously, because this will lead us some pointers always on top. Yeah, that's fine. So now I can say, as you know the syntax, if serial.available function, that means there is some data to read, is greater than 0, then do some operation. Then do what? Then read serial dot, and we know that read function reads in ASCII, so we'll use serial dot parse int, which will read in directly integer. And let's store it in a value, say rx. Okay, and based on rx, now we can say if, or simply we can use a case statement, switch rx, and let me wrap this code. Okay, switch rx case 1, if 1 is the number, 1 is the integer received, then serial dot say print. Now we have to save for 1 what we have to do. So 1 is square root. Now we will ask user to enter value for square root. So let's say enter value for square root. Okay, next is, now here serial dot, now here this is important. Now we are in a difficult situation, because now again we have to read serial value which user will enter, because we are in a loop, and this loop will only work if the first value is selected. Suppose case 1 is selected, and here we have to again put another loop which will find which value has been pressed. That means we have to put a while loop here to continuously monitor whether data is arrived or not. Okay, to show that situation, let me move further. So what we will do is, if serial dot available greater than 0, means there is some value to read. And remember, after the serial dot available is greater than 0 and we received a serial dot parse int, the serial buffer gets cleared. Same with read function. So the moment you read 1 byte, the serial buffer gets cleared. So it's important. It has a timeout, I guess. So it's important you keep you grab all the data at once, otherwise you will be losing serial data for that instance. So again, we are using a serial.available, and we are checking whether any serial data is available, and this time we are expecting it will be again it will be a number entered by a user which he wants to find the square root of. Okay, so serial.available, again let me put curly braces, and int, let I say square, the value something, some variable, serial dot parse int. Okay, and let's not do the square root operation here. Let's simply do print ln square. We will do the square root operation later. So let's upload this program. we are hoping to grab the number also, enter the value of square root if user select 1. Okay, so let's upload it. Println was not okay, sorry, serial.println, and again we are missing some braces. So this is for case, switch case, this is for if, and this is for this if loop, and this one is extra. Upload is done. Let's select 1. It says enter value for square root. Now if I enter, I want to find the square root of, for example, 4, and I hit enter, nothing happens. Can you guess why it happened? Why it didn't showed any result? Because we have printed serial.println here. The reason is simple, because it's an infinite while loop. This complete function, this loop, void loop, is huge. Okay, so what happens here is, the moment the control comes from void setup to void loop, serial.available is checked once, okay, in the void loop in the first iteration. So moment it received 1, it came to this position. Okay, so we are here, case 1, it printed the serial.println. Immediately, there is no delay here, immediately it is looking for serial.available, right? It's looking a momentary, means the next moment it looks for serial.available greater than 0, and it doesn't find, because we haven't entered the number 4 fast enough to get into this if condition, and that is almost next to impossible that we can enter 1, and after showing up this, immediately within the fraction of second we will enter some value here which will be grabbed by serial.parseInt. That is very, very difficult. Okay, so one solution is we have to keep this inside a while loop which will continuously check whether user has entered a value or not. That means whether serial.available have a data or not. If it will have a data, it will then take that data and show it to user. Okay, means make it available for square function. I hope you understood this part. So this part is running very fast, so that's the reason we are unable to send data in the correct time so that this function can receive it. One possible solution is keep this function in a while loop which will monitor continuously until serial.available has some data, then only it will break. But that solution I won't recommend, because that is not scalable. So the best solution for such a condition is creating a separate function, we say read from PC function. Let's define that, and that function will take care of reading data from serial terminal. For example, I define, let's start coding that. Let's say a function we write read from PC. Okay, and here we are, and this function should be a common function for even for this condition where we are looking for the first conditions where user check from the main menu whether he want to use 1 or 2, or this condition where inside the case statement we are looking for the same set of input from user. So here what we will do is we will write a while loop. You know, only 2 functions are mandatory, setup and loop. You can write as many other functions you want. So in this other function we have to write a while loop because it doesn't automatically run forever. So while serial.available equals to 0. Okay, so why we have done equals to 0? The reason is, and you can see we have closed I have closed here the semicolon. That means this loops ends here. So stay here. Okay, let me write it down. Wait until data from PC. That means I'm saying that be in this while loop unless you get some data. So this condition will fail as soon as there will be a data, and this while loop, this 0 won't be true. So as long as there is no data, this is a true statement, and the program will stay here forever until there is a new data from serial terminal, okay, from PC. Okay, moment it gets a data, what you do, you return data as serial dot parse int. Okay, and why parse int? Because parse int returns long integer value. Let me write that on also. So parse int function returns long integer value, unlike serial.read, unlike read function, or better we say serial.read, right, which returns only 1 byte. That also we can write, which returns only 1 byte. Okay, so now instead of using all this code, we will simply use the switch statement, and switch here, let me modify, and let's call this read from PC function, read from PC. Why we are doing so? It's very clear. So we immediately want to know what is the main menu content, which content from main menu is selected, either it's 1 or 2. So read from PC function will tell that. So when read from PC is called, it will go here and it will stay until the new data is available in this while loop, and moment some data is available, it will return the serial.parseInt. So some data, and the return is it's not void, it should be return type is integer, and the return type will be stored here as either 1, 2 or some value. Some other value will be ignored, and for 1 it will come to case 1. In the case 1 we have this statement is correct, this can stay. Here we don't have to look for if condition again. So what we will do here is we can simply remove all 3 lines, and here simply we can use serial dot println. Okay, first we want to view the data. Okay, serial dot println read from PC. Is it correct? Yeah. So this is for case 1, case 2. Again fine, I think the braces are correct. Let's upload. So step by step we are moving forward, and let me select 1, enter the value for square root, let's say 4, and we get 4. Okay, so far we are good. And for finding a square root, we need not write detailed code. In the Arduino, the downloaded zip file, the Arduino IDE itself contains a function math.h. So we'll simply include that function here. Include math.h, and this math.h is a standard function. So this is my home directory in Windows. You will be in somewhere documents. So this is a downloaded zip file. Going to hardware, tools, AVR, include, and this math.h is available in the AVR function itself. Sorry, in the original AVR function. Sorry, original AVR library. Okay, so this is not exclusive to Arduino, so this header file can be used in many embedded platforms. So you can see here it is written okay, so math.h, mathematical functions, author Mr. Michael Stumpf, and some more details. Here you will find some macros. At the end you will find the list of functions which it supports. So I have taken some functions from here. So you can see there are trigonometrical functions. Let me find them. Okay, So let's search for square root. So sqrt is the function, I know that, and there are 14 such things, but I know it's somewhere here. Yes, so this is the function, extend double square root, and that's it. It takes one value, one double value. Okay, so if you're interested, you can go to this header file and look into other mathematical operations. For now, we don't need this, and we can simply proceed further. Okay, so I have included math.h because it's a library from a given path. I have to include in double quotes. Or does it work with this also? Let me try. I don't know. Okay, so read from PC, we know this. So why don't, instead of printing, we can simply do we can directly print square root sqrt, and I hope it will work. Okay, so we are doing sqrt is a function in the math.h, we already know. So sqrt read from the PC. So what is read from the PC? Read from the PC will return 4, for example, and find the square root of 4 and do a serial.println. I hope this should work, and it worked. So math.h is a function accepted in the Arduino IDE. So let's select 1 because 2 is not programmed yet. Enter the value for square root. Fine. So square root of 4 is 2, square root of 5 it won't take. So what you have to do, you have to press 1 again and select the program. So enter the value of square root. Okay, so let's say 5 is 2.24. So we'll play with the calculator later. So let's finish our program first. And what is our next case? So case 1 is done, and we have to okay, let me do a small decoration. Serial.println. This will look pretty. Okay, and we have to, of course, say break if we wish to use. So case 2, I think I can copy these lines and move accordingly. Now this should be 2, and here we can say, okay, for our second program, our second calculator application is power of integer. So find a power of integer, you need 2 input values. One is base, another is power. So first user has to input base. It doesn't matter first which one, but normally we worry about base first. And let me remove it completely. Serial.print, and let's store that in a float base. Let me take a float type variable. It supports float. Read from PC. So this will return a value, maybe in a float form also. And let me print this value. Serial.println base. Okay, so similarly enter the power. Serial.print. Let me give some space so that I don't have to type 2 again, it won't look good. Enter power value, and we have to receive it. Float in a power variable, read from PC. Okay, so let's print the power value also. So serial.print ln power, and let me give some space in between so that it's easy to read. Nice. And Now we have to find the calculation. We know there is a function POW, which is power, and for that we can do a small decoration, serial.print. Okay, let's see how it looks so far. Are we going right? So now we will select 2, enter the base value, let's say 4, enter the power 2. So far good, fine. So we have to do 4 into 4 and show the result. For that, let's say float result equals to power base comma power. Okay, so this result we have to print serially. So serial dot println result. That's it, I think so. Power of integer, so base value say 4, power value is 2, and the result is 16, but it doesn't appeals as 16, appeal as result. So let me do a small print statement here, serial dot print. So what is different in print and println? Simple print doesn't give a new line, whereas println prints with a new line. So power of given values, given value is whatever. So okay, so this will now go to, I hope it should work. I think that's it. Okay, so let's start our program. Let's start with first square root. Enter value for square root. Okay, so let me give a larger number. I hope 111 will work. It works. So now again we are in the main menu. It doesn't show it. We can modify the program to make it show it again, clear the screen and write a main menu. That anyway you can do later. Power of integer, base value let's say 6, and power is let's say 6, so 6 multiplied 6 times, and here's the value. Is it correct? I think so. So surprisingly it looks correct, and because we have chosen floating point values, so anyway because it's an 8-bit processor and there are some limitations to it, the answer is correct. I verified in my other terminal. That's it. So let's get a quick revision. Let's come to the top. We have included math.h for 2 functions. What are 2 new functions? Power and square root, sqrt. So initially we tried okay, so void setup, let me expand it, is a plus icon. Okay, so serial.begin, you understand it's beginning of serial port, serial communication. Serial.println, this is a menu which we have printed once. Next comes void loop function, the switch statement to select the menu entries 1 or 2. Okay, and in the switch statement we are simply calling a function read from PC, and read from PC is here, which continuously monitor whether any serial data is available or not. So this can be used for, this can be extended to any such serial programs which you will encounter in near future. And this immediately, whenever the data is available, it immediately sends us an integer value. At many times you don't need integer, you need simply character or bytes. Okay, so you can read, you can use, instead of serial.parseInt, it's better to use serial.read. So in the case 1, we are in the square root function, simply print square root read from PC. So this function calls the read from PC, and the value which it receives, it finds the square root of it using math.h functions, math.h library, and it prints the value. And you can see the value here, 10.54. Break, so it comes out of this loop and this loop again starts, and the moment loop starts again, so it again goes to switch statement. So the switch statement, when it goes, it again goes to read from PC, and here it waits for user input. So again, if you press 1 or 2 based on our menu entries, it will go either in first or second function. Again, suppose it enters to the second case, enter the base value, read from PC, same. You take the base value in float and power value in float, and simply do power function base into base comma power, which will return you the power of that integer. And that's it. So this is a simple calculator made with serial communication. Hope you enjoyed it. See you in next video.